Hi friends, welcome to Civil Learning Library for the topic Tension Member Design Part 2. For Part 1, please see description for link. Generally, we have so many type pin connections like this kind of rectangular or circular or I-bar tension member. In this presentation, we will see this kind of rectangular arrangement pin connection tension member. Okay, for this connection, first we will assume the load. We are assuming that dead load is coming as 40 kilonewton and live load as 10 kilonewton for this particular connection. So as per LRFD, we have to factor the values. So for dead load 1.4 and for live load 1.6. So 1.4 into 40 plus 1.6 into 10, we are getting 72 kilonewton. So we have to check this connection is okay for this 72 kilonewton. We are assuming that yield strength of this material is 250 and ultimate strength is 400 Newton per mm square. Then we will assume all other dimensions. We will assume the plate thickness as 12 mm. This plate is 12 mm. Then first we have to do the dimensional checks. There are some criteria is given in code to check the dimensional checks for this particular plate. So the first one is B effective. B effective is nothing but this distance. This distance minimum should be 2t plus 16. So 2 into t is nothing but the thickness plus 16 mm. So we have to keep minimum this distance as 40 mm. So here we will keep some margin and we will keep this as 50 mm. Then second condition is this A dimension should be greater than or equal to 1.3 B effective. A is nothing but this dimension, edge of the hole to the edge of this plate. So from this 1.3 into B effective we calculated as 50. So this dimension should be 65 mm minimum. Then next condition is width of the this plate. So here width should be greater than or equal to 2B effective plus DD is nothing but this diameter. Okay, so 2 into B effective is 50 plus we are assuming that this hole is 20 mm now. So then our width should be 120 mm minimum. And the fourth condition is C dimension should be greater than or equal to A. C is nothing but this cross dimension. This dimension should be higher than this A. So if you draw these values like this width and this B, here we are getting the C value is greater than A, approximately 75 ohm. Hence, our dimensional check is okay for this presentation. Totally 4 checks we have for this pin connection tension member. First check is tensile rupture strength of this particular plate. So to find out the tensile rupture strength, the formula is 2T into B effective into FU. So 2 into T is thickness 12 into B effective is 50 into FU is ultimate strength of this particular plate, that is 400. So we are getting 480 kilonewton. So for design tensile rupture strength, we have to multiply with factor of safety. Factor of safety is 0.75 for LRFD. So 0.75 into this 480. So rupture strength capacity of this particular plate is 360 kilonewton. Then we have to do same thing for shear rupture strength. To find out shear rupture strength, the formula is 0.6 FU into ASF. FU is here ultimate strength. ASF is nothing but the area of this particular portion, approximate area of this particular portion. So we can use the formula also to calculate this ASF, that is 2T into A plus D by 2. So we know that 2 into T is thickness plus A value we already calculated earlier, 65 plus diameter by 2. So from this we can calculate the ASF. So our design PN is equal to 0.75 is factor of safety into zero point 0.6 into FU is 400 into this area A is 1800. So the capacity for shear rupture strength is 259.2 kilonewton. So here just I kept other values which is assumed earlier, T, B effective, A, W, FU and Fi for easy reference. Next, check 3 is bearing strength. The formula for bearing strength is 1.8 Fi into APB. APB is bolt bearing area. So that is nothing but the diameter of the hole into the thickness of the plate. So here we can get APB value. Then we have to multiply with design factor of safety 0.75 into 1.8. Fi is 250 and APB is 240. So we can get the value as 81 kilonewton for this particular connection. Then check for is tensile yield strength. For tensile yield strength, the formula is FIAG. For tensile yield strength, factor of safety value is 0.9 into Fi is 250 into AG. AG is nothing but the total area width of the area. So with this, we know that 120 into thickness is 12. So we are getting 324 kilonewton as a tensile capacity for this particular plate. The final capacity of this connection member is least of these four checks, which is coming on bearing strength 81 kilonewton, and this 81 kilonewton should be higher than the our record tensile strength capacity of this particular connection, that is 72 kilonewton. Hence, this is okay. If this is not satisfied, then we have to increase the plate thickness and other dimensions accordingly to satisfy the criteria. Hope this presentation is useful, and thank you for watching the presentation. Please like and subscribe to get notifications and more videos.